Okay, A2Hers, we are back with the law of cosines, and again, this is something that you already touched on in geometry some. We are going to use the law of cosines to find angles and sides, and then we're also going to talk about Heron's formula, which is used to find the area of triangles. So when do you have to use the law of cosines instead of the law of sines to solve triangles? That's when you have SAS or SSS information. So remember, SAS is two sides and the included angle. And then side, side, side would be you're given all three sides. So if you're given all three side lengths. Here are the law of cosines. So that's the same formula. It's just this would be to find side A, side B, side C, but you can also use it to find the angle measures when you solve for them. Again, you would need to use the inverse if that's what you were doing. And then whenever I introduce the law of cosines, I like for you to notice some of the patterns. So one of the things you might notice is that it all starts with the Pythagorean theorem. A squared equals b squared plus c squared. B squared equals a squared plus c squared. C squared equals a squared plus b squared. So it's similar to that. It's obviously not the exact same thing because c squared equals a squared plus c squared is what it is. And then the angle at the end, if you're doing the cosine of a squared is at the beginning. B squared is at the beginning, c squared. You might also notice that if you have an A here, it shows up here. If you have B squared, the B shows up here. So those are just little patterns that you can notice to help the formula stick in your mind without having to go back to it each time. We are going to use the given measures to solve the triangle, which again means you're going to find all the angles and the sides. So find all the angles and your sides here, and then we're going to round to the nearest tenth. So the first thing we want to do is draw a picture. I'm going to just draw ABC as we have been in the last section. Honestly, that part doesn't matter as long as the lowercase a is across from the uppercase. Lowercase b is across from angle B. And then the measure of angle C, and then this would be lowercase c here. So in this situation, this is side, angle, side. We're given a side, an angle, and an included side. That's how we know we are going to have to use the law of cosines. So if you're given angle C, you can use this as a reference. So this is going to be c squared equals a squared, which is 8 squared, plus b squared, 5 squared, minus 2 times a times b times the cosine of c. Now this, you can input that all into your calculator at one time. That is perfectly fine. A lot of times what I'll do is I'll calculate these myself, the 64, the 25, and then I just have to rely on the calculator for less things, like you could add these two together. So this is 89 minus 8 times 2 is 16, 16 times 5 is 80, cosine of 32.2. So 89 minus 80 times the cosine of 32.2. Again, mode should be in degrees. This is not going to give you c. This gives you c squared. So do not round it yet. You can see I put the dot, dot, dot. That shows that I did not cut that off. You are taking the square root of the answer. So in your calculator, you do second square root, and then you're going to use your answer key. Okay, so you have to square root the answer. Do not round that. You're only going to round until the end. Oh, sorry, I didn't put my... So second square root, and then second answer. Okay, and that means your c value is about 4.6 when you're rounding to the nearest tenth. Now, once you know what c is, now you can use the law of sines. What you would want to do is find the measure of the smaller angle first. There are certain orders that you want to to find these in to avoid the ambiguous case. And how would I know that angle B is smaller than angle A? That's because the side length of B is smaller than the side length of A. So now I have a matching pair. I'm going to use the sine of 32.2 degrees over 4.6, and this is a rounded value. So the smaller angle would be B, so this is going to be the sine of B over 5. Okay, so then if I'm finding the measure of angle B, I'm doing the sine inverse of 5 times the sine of 32.2 divided by 4.6. So 5 times the sine of 32.2, close your parenthesis, divide by 4.6, and then I'm doing the sine inverse of that. You can put it all in at one time too, I just didn't for that one. So that would be 35.4 degrees, and that's the measure of angle B. And then once you found that, you can find the measure of angle A by subtracting. So 180 minus 35.4 minus 32.2 is going to give you 112.4 degrees, and so that is your measure of angle A. So now you have all three angles and then all three sides.